Lagrangian, and then you could define the integral as the action. Then we could define what is the classical mechanics. For the quantum mechanical system, the coordinate and the conjugate momenta, they are now not variable. They are mapping. So the for the mapping, you can define the so-called commutation relation and so on. So classical field, in fact, the definition is the same as the classical mechanical system, except in the field we have a continual meaning. Same for the quantum field. Again, so if you look at so what is the message here? In fact, there is no so-called infinite electron C. There is no second quantization, only one quantization. This is so far a consistent language. Maybe it's also complete, we don't know. So let's come back to the dark matter question. So what is the dark matter? Can we describe it or describe that? If yes, what would be the language? So the first guess is follow the QHP language. So in other words, we try to solve for the standard model. In fact, game theory, with or without Higgs mechanism. If not, what else? So in what follow, I would wish to present that in the four-dimensional Minkowski space-time with this group structure, force field structure. So there is this we call a standard model with the 1, 2, 3 for a quark, another 1, 2, 3 for a lepton. So I would try to describe the structure, my struggle for over maybe 30, 40 years. So in fact, in 97, I think of a Z prime. At that time, a lot of interest in Z prime. Then I think that if we have a Z prime, then there is the new Higgs field. So the Higgs, in other words, it depends on whether Z prime exists or not. So my question is that how to add a Z prime but with the minimum number of Higgs field that is I try to publish in a paper. The other question, in fact, is also the source of confusion. So we know that you could add a so-called right-handed or left-handed. That also a way to add the new gate boson. In fact, if you try to do it, Mahapatra, Patty, and Salam, they have many papers on that. After thinking a lot, so the thought of mine in December 2012. In fact, why the weak interaction break the left-handed symmetry is one of the deepest questions. But after thinking it over, I think the party and the Mahapatra, in fact, it violate some rule. In other words, every beginning point, you have to write down, this is the kinetic energy term, this is the potential. But for the party and the salam, you have to do it twice. Because it's twice, so it could be would be not accepted. The other question is I have mentioned this earlier on. In other words, why should we have the standard model case, the Higgs in the electron weak sector, but not in the strong QCD case? This I call struggles number 2. In fact, this question, over the last 35 years ago, at that time I already thinking of this when I was a student. Either. So the question I asked my advisor, Henry Permacourt, in the 70s, I asked him one day. He asked me, wait a minute, he had to think about this. That's the question, renumeratable. Whether it's the principle or simply working rule. My advisor, after thinking this for a few days, come back to tell me maybe he would regard renumeratability as the principle, first principle. at that time, maybe in 1975, Stephen Weinberg was in a committee with the committee for visit the graduate student at the UPenn. So I get maybe 20 or half hour to ask him questions. At that time, he haven't received the so-called Nobel Prize. But I asked him two questions. The same question to the private call. But I remember that he doesn't have time. So for second thought, he thinks it's not. In other words, principle of normalizability wouldn't be the first principle in Weinberg's mind. I also asked the question that why the strong interaction you don't have the Higgs mechanism. But at that time, my understanding of the question still a little bit vague. So I don't remember how he answered that. The reason I said here, that I'm standing here, is in fact, I have the so-called cerebral hemorrhage. And in fact, 4 years from that, 2004 to 2008. In fact, at that time, I come back to the UPenn to attend high energy conference. In fact, at the 2 or 3, I woke up one night to ask why the idea of a color Higgs mechanism, why I don't copy that to describe the family SU3 gay theory. Except, you know that we have to have all the particles being massive. In other words, there is the Higgs mechanism. So, in fact, during the time I have the basic is a simple idea, except you will have to work out with that. Illusion, in fact, to have the reason to try to rewrite the so-called standard model. In fact, you could see this. In SU3, if you want your A gate boson to be massive, so you have to at least a pair of complex scalar field. This will have a 12 zero field. A coming back, come to the gate boson, the longitudinal component, or so four Higgs remain there. In fact, this get to be a little, this is a general idea. This only show you how to get the mass from Higgs. In fact, 2 years ago, I went to the Groningen and to attend the so-called SIP 2012. And then someone, in fact, a Japanese friend, is talking so-called lepton flavor violation. Then I realized that those reactions, in fact, is the same as the neutrino oscillation. So, because of that, I am quite the theory is very good. In other words, neutrino oscillation, in fact, is the same as the lepton flavor variation, including mu gamma, mu pi zero decays into the mu nu. In fact, you have to introduce this. This is in fact a left-handed triplet, doublet, left-handed. This is right-handed. So that's why you have a 3-2 hit. In fact, this quantity is not a standard matrix operation, but a unique SU3 operation. The unique singlet out of the 3 given triplet, and from left-handed, right-handed as usual. So this is how is the acting on the lepton space. I should tell you that, in fact, I tried to submit archive at 21 December 2012. Maybe you don't know, December 21st is the end of war due to, according to Maya calendar. So I submit this. I thought I would register as 21, but it's in the morning here. The Cornell they are starting a little bit late. So this is the struggle with the standard model, the part number 6. So after that, I think that I have to do is to try to work out the so-called Higgs and everything. So that's why we already have the 532 and also standard. The other one is this one for the randomizability. So that is the reason I submit this paper. So using that, the potential, there are so many terms to the fourth power or in the field. That was 1.5 years ago. Then you can determine the so-called U gauge. The U gauge, what it look like. So 1 to standard model is the same thing. And 3-2 have because of neutrino oscillation. So there is the U1, U2, U3. And also this one. Triple have 6 independent components. So 5 of them get eaten by the gate boson. So only 1. So you can work it out. In early May, the last May, I realized that such a complicated Higgs Lagrangian doesn't do any good for us. So that's why I have the idea, the origin of the mass. In fact, to begin with, I would try to use the electroweak spontaneous symmetry breaking to do everything. And in fact, I already write a paper on that. Then I realized that, in fact, the term is coming to the 3-1. 3-1 could do everything. You should understand this all. So the important rationale would be we have the 3 Higgs, the so-called 512 standard Higgs, 532 mixed family Higgs, and the 531 purely family Higgs. And in fact, we know that 532 how it arises. In fact, you should realize that this scalar field, it looks like a field of a bunch of the energy. So in other words, it's the energy. Therefore, it should be bounded from below. This is in fact the so-called positive definiteness. Remember, so I have nothing else in a mass term except this one. The lambda is have to be some pure number. So, in the four-dimensional Minkowski spacetime, this is indeed very unique feature. So lambda is a pure number. The most magic effect comes from that. So you could realize that this Lagrangian try to go to the temperature much higher, then the mass temperature would be disappear. So that's the idea. So there is one ignition term, this term. Why there is no others? My rationale is that the gas would ignite once, not twice. So it's this term, only this term. In fact, I started thinking about this SU family street. Why is the really is? In fact, if you look at the mass of a gate boson, is the tens of GeV, or maybe that would be the sub-Fermi family gate boson. In other words, the atom is would be 6 or 7 orders away. So if there exists atomic physics, chemistry will have no way to see that. But in fact, if you do the high precision G-2, it may be a way to go. All right, huh? So using the remaining 5 to 10 minutes, in fact, everything is very nice. So the next thing we have to think about whether this is a complete theory. So in other words, if you try to calculate all the divergence, that I already started on the quadratic part. Quadratic divergences to investigate whether this can be done or not. In fact,